complementing the general principles that we've seen, organizational principles and technical principles, which are common to all or most agile methods, are a number of principles introduced by specific methods, although they carry a general value and are worth studying. We will take examples from Scrum, from Crystal, and several from the Lean software approach. The first one indeed comes from Lean. Mary Poppendieck. We have already seen that the notion of waste, and in particular the notion of fighting waste, is central to Lean software, and we have already seen the 7 wastes of manufacturing and their counterparts for software as seen by Poppendieck. To complement this analysis, here's a more detailed checklist of stuff that constitutes waste in Poppendieck's eyes, and this is the kind of thing to be on the lookout for in software development. Unnecessary code, unnecessary functionality, delay in processes, unclear requirements that are going to delay you and hence cause waste, insufficient testing, which is going to lead to bugs that surface far too late in the process, repetition in the software process if it could be avoided, bureaucracy that stands in the way of effective development, internal communication that is too slow, coding that is not finished. A piece of code that is almost done is almost as bad as not done at all because it doesn't produce any working functionality. Waiting for processes to finish, waiting for some other team or some other team member to complete his or her work, waiting for other activities, waiting for customers to tell you what you need to know from them. Bugs, of course, defects, lower quality, and anything managers do that instead of helping actually harms the process. So this is a quite useful checklist that you can keep to monitor your projects and make sure that they don't produce waste. Now the reverse of waste is learning. We are going to have, after this negative list of things that we don't want, that is to say waste, the other side of the coin, the positive side of the coin, what we try to maximize and rather than minimize like waste, and it's learning. Learning also meaning information. Many of the mistakes we make which cause waste are due to insufficient information. We are in a tunnel looking for the light, looking for the end of the tunnel, and anything that sheds a little light is going to help us. Or maybe the appropriate metaphor is a maze with not much light, and anything that enables us to find our way through the maze of developing a software system is going to be welcome. And how do we amplify and speed up learning? Well, we know that in agile methods it's important to run tests all the time. We're going to come back to this in the study of test first development as part of practices. The justification for this in the Lean view is that it helps prevent the accumulation of defects. Tests give you learning, tests give you information. Instead of documentation, which would be one way of producing learning, the agile view is, in particular the Lean view, is that we should try different ideas by writing perhaps different variants of the code, and it may be more effective a use of our time than to write documentation. Just try different solutions and see which one works best. Another way of gaining information is to present some results to end users and get their input. Also, short iteration cycles are justified here by the goal of amplifying learning. That is to say, they give you immediate feedback and they provide you some light, helping you to get out of the maze. And another example is feedback sessions with customers. So the important notion here is learning. The more we learn, the less waste we are going to produce. Yet another idea, perhaps more controversial from Lean, is decide as late as possible. So the idea is to delay decisions as much as possible in order to avoid making decisions for which we do not have enough information. The danger here is to decide because we have to decide, but we don't have the information that enables us to make the right decision, and then we either have to live with the wrong decision or at a high cost correct the decision and scale back. So the justification here, for example, for the iterative approach is that it enables us to postpone some decisions and make sure that when we make the decision, we have the right information. Now, this is in principle a good idea, of course, but we may also note that sometimes it's better to decide something than not to decide at all. Procrastinating is not a good way of managing a project, and the idea of plans, which is much criticized by agile methods, is in part to help us assess the various elements of information early on so that we can make the decisions and, if possible, make them early. An idea from the crystal method is focus. Alistair Coburn tells us that it's critical both for the team as a whole and for individual in that team to keep focus, meaning not to disperse themselves too much. So, for example, he criticizes the common practice of having developers active on several tasks at once, which decreases focus. So it's better to focus on the individual task of the moment rather than to do everything at the same time. This ensures flow of progress, and one precise kind of advice that he gives is to deal properly with interruptions. One of the banes of software development, in his view, is the constant occurrence of interruptions for developers, and so he suggests, for example, having a rule that there are 2-hour periods without any interruption whatsoever, and he also criticizes the current practice of switching developers from project to project or from task to task too often. So, for example, assign developer to a developer to a given project for at least 2 days before switching. Actually, 2 days doesn't seem that much to me, and here I would go further than him and say make sure that people are not switched from project to project more often than every few weeks. The focus is also for the project as a whole, and ensuring that everyone has a clear and shared vision of what the project is about and where it's going, so that everyone is, so to speak, paddling in the same direction. Another idea from Lean and Scrum: deliver as fast as possible. The view here of Mary Poppendieck is that it's not the biggest that survives, but the fastest. So the sooner the end product is delivered, the sooner feedback can be received. And she transposes to software the just-in-time production ideology. Once again, these ideas that have to be considered with some distance, because the history of software development is also littered with companies that went too fast to market, like VisiCalc, for example, that opened the market for spreadsheets, which was then taken over by much bigger fish. So be careful here of not just believing a single anecdote like the one that I just gave, or any which would go in the other direction. One has, in good engineering, to weigh the pros and cons rather than apply simplistic recipes. Another advice that Poppendieck gives is to try multiple design. That is to say, to have several teams compete. Well, this is something that has been proposed many times before Agile in software development, and the industry doesn't do it very much, mostly for cost reasons and also because developers tend to fall into the same pitfalls, so you would have to guarantee that the teams are really different. But still, it's an idea to consider. Something more fundamental and highly subject to discussion, going back to our discussion of user stories, is the implicit idea behind the use of user stories as the basic for requirements, the implicit idea that you can actually pile up user stories and obtain requirements. Now, the promoters of Scrum, in particular Jeff Sutherland, go quite far in this direction and assert that it's possible to remove dependencies between user stories so that at any point the team can select any user story from a kind of queue of user stories because there are no dependencies between them. So this is, if you think about it, an essential assumption behind the use of user stories as the source of requirements, and this idea that every morning the first person available in the team is going to pick the next user story. And this is really, to be quite open about it, more like a fairy tale. So to be more precise, it depends on the kind of system that you have, and here we can talk of two kinds of complexity: additive complexity and multiplicative complexity. We can also talk in more culinary terms of the lasagne kind of complexity and the linguine kind of complexity. These, of course, are only metaphors, but I think they carry the idea well. So there's a kind of complexity that is quite susceptible to working by subsequent user stories that you just pile up. This is the lasagna kind of complexity, where the various pieces of functionality are independent from each other. Assume that you have a system that supports a version in English, a version in French, and a version in Spanish. If you're asked to produce an Italian version of it, it's probably not going to be too hard because it doesn't interfere that much with the existing functionalities. On the other hand, much of the interesting and difficult stuff in software happens when we have linguine style complexity. That is to say, the various features are so intricately intertwined that it's difficult to touch anything without pulling off everything else. And this is what makes software difficult as well as interesting. And if you have that kind of feature interaction, the idea that you can just take the next feature, the next user story, and work on it without interacting with what already has been done just belongs to the realm of fairy tales. And we have very good source for this observation. Pamela Zave, who has been all her career at AT&T studying and building telecommunication software. Telecommunication software is often feature-based, and she shows the limits of this approach. She says in telecommunication software, feature interactions are a notorious source of complexity, of bugs, of overruns, and bad user experiences. And she gives many examples. I'm only including two here, but I strongly urge you to read her article, starting with her webpage, which already has a lot of material. So call forwarding and do not disturb. Well, one person has call forwarding, and his assistant has do not disturb, and the two features have not been planned together. So someone calls Bob, the call is forwarded to Carol, and Carol phones, which shouldn't ring, does, because do not disturb is not applied to a forwarded call, and everyone had missed that. Or the case of a sales group where the feature is select anyone from the group, but one of the members of the group has forwarded the calls to his personal cell phone and sends a great greeting message to the customer, which is probably not what the customer was expecting when calling to buy a laptop. So this is typical of what happens when you try to mix features just to pile up features which do not pile up naturally, and this shows that just relying on the succession of user stories implementation is just not going to work. If we had been asked to write the user stories corresponding to this telecommunication example, we might have had a user story which gives the redirection specification, and the next one which gives the mechanism, the procedure for busy actions, then one which gives the salesperson interruption mechanism for important customers, and so on. So each one of these by itself looks great, but then if you just put them together, they just don't make sense anyway, and there's no substitute for abstracting from individual user stories and looking for the requirements of the system as a whole. A couple more principles coming from Crystal, more on the personal side. Crystal emphasized the human nature of software development very much. Personal safety, encourage free expression of ideas. Alistair Coburn tells us, do not ridicule anyone. This is more like good practices in a team. And humanity. This is in fact from Extreme Programming. It goes in the same general direction. It's from Ken Beck's book on Extreme Programming. Recognize that software is developed by people. This also comes very much from the influence of the peopleware work by Lister and DeMarco, which I mentioned in a preceding segment. So offer developers what they expect, safety, as also pointed out by Crystal, accomplishment, belonging, growth, and intimacy. So that's an important aspect of the Agile method, the emphasis on the personal side and the respect due to programmers. What we've seen in this segment is a set of important ideas from all four example methods of this course: Scrum, Lean, Crystal, and Extreme Programming. And some of them are minimize waste and maximize learning. The two go together. Accumulate user stories, again as a mechanism for requirements gathering, and we've seen the really strict limits of that approach, which is highly subject to criticism. It's not among the best contributions of the Agile method. And ensure personal safety and humanity. This entire focus of the Agile approach on providing programmers with a safe environment and respecting the personality of individual members of the team.